Now, to example number 7, if you check it correctly, we say it is a linear differential equation because the highest order is y prime prime and it is raised to power of 1. Y prime prime, which is a third order of the differential equation, and it is raised to power of 1. Therefore, we say that number 7 is a linear differential equation. On example number 8, we say that it is a linear differential equation. Reason because the squared y over ds squared is the highest order in the equation. The y over ds is a first order. The squared y over ds squared is a second order. Therefore, this second order is the highest order in the equation, and it is raised to power of 1. That one is spiritual. Since it is raised to power of 1, we say it is a linear differential equation. To example number 9, if you check it correctly, you will know that it is a non-linear differential equation. Reason because the highest order in the equation is the squared y over ds squared, and it is raised to power of 3. And one of the conditions for non-linear differential equation is whenever the highest order in a differential equation has 2 or more as the power, then it is a non-linear differential equation. Remind you, the highest order in this equation is this, which is the second order. This is a first order, this is a first order, but this is a second order. Therefore, this second order is the highest order, and it is raised to power of 3. Therefore, it is a non-linear differential equation. Example number 10, y dx over y dy over dx plus 3xy is equals to 0. We say that this is a non-linear differential equation because y is multiplying y prime. Y, it is y, the y over ds is the same thing as y prime. Y is multiplying the first order, which is dy over dx. Whenever y is multiplying dy over dx in an equation, that equation is non-linear. Whether y is multiplying y prime prime, that's y is multiplying the squared y over dx squared. Whenever y is multiplying the cube y over ds cube. Whenever y is multiplying any order of a differential equation in an equation, you know that that equation is non-linear because one of the conditions is whenever y is multiplying y prime prime, whenever the coefficient of our derivative y, whenever the coefficient of our derivative is y, that differential equation is non-linear. Then we move over how to identify a homogeneous equation and an autonomous or non-autonomous equation. Okay, to identify whether an equation is homogeneous, you must make sure the power of x is equal to the power of x at the numerator will be equal to the power of x at the denominator, and it will be equal to the power of y at the numerator, and it will be equal to the power of y at the denominator. The power of x at the numerator must be equal to the power of x at the denominator and must be equal to the power of y at the numerator and must be equal to the power of y at the denominator. For example, in this equation, we say that it is homogeneous. Reason because x has a power of 2 at the numerator, and at the denominator, remind you, x has a power of 2 and y has a power of 2 because x and y are married here, and when they were alone before, when they were single before, they has a power of 1 each. When they were single before, they has a power of 1 each, but they are multiplying each other. Now they are married, so that's their power. You add their power with the law of indices. In the law of indices, whenever you see something like this, you add the power together. That is why 1 plus 1 will give you 2. Therefore, the power of x and y at the denominator is 2. Therefore, we say this equation is homogeneous because x has a power of 2 and y has a power of 2. And at the denominator, x has a power of 2 and y has a power of 2. In example number 2, x has a power of 1 and y has a power of 1. They are single here. And at the denominator, x has a power of 1. Single also. Therefore, x has a power of 1 and x has a power of 1 at the numerator and is the same thing with the denominator, and y has a power of 1 at the numerator. Therefore, this example number 2 is also a homogeneous equation. In example number 3, we say that it is a homogeneous equation. Reason because x has a power of 1 when it was single, y has a power of 1 when it was single, but here they are married, so their power will be added, and when their power is added, it will be xy raised to power xy all raised to power 2. So x has a power of 2